Hey everyone, and welcome. Today, we're going to dive into some of the hidden chemistry that's happening all around us every single day. We're going to solve a colorful little mystery you've probably seen in your own home, and the biggest clue might be on your clothes right now. So has this ever happened to you? You spill some curry, you get that classic yellow turmeric stain, you run to the sink, scrub it with soap, and bam, that yellow stain just turns bright red. What is going on there? It totally looks like magic, but I promise you, it's pure science. Okay, so that crazy color change from yellow to red, that is our number one clue in this little chemical mystery. It's a huge signal that two very different kinds of substances have just crashed into each other. And stick with me because by the end of this, you are going to know exactly why that happens. All right, to get to the bottom of this, we need to meet the main players in our story. You know how every great mystery has its opposites, right? Well, in the world of chemistry, our key players are acids and bases. And these two, they're not just some obscure chemicals in a lab. They are absolutely fundamental to our daily lives. So let's dig in and break down what really makes an acid and a base a base. So this table here really lays it all out. When it comes to how they feel or taste, think about it. Acids are sour, right? Like lemons. And bases, they're more bitter and they feel kind of soapy or slippery. But the real key, the chemical difference, is what they do in water. Acids release these things called hydrogen ions, while bases release hydroxide ions. That's what gives them their unique properties, and it's exactly why they have opposite effects on a litmus test. Makes sense, right? And listen, this isn't just some abstract stuff from a textbook. These things are literally everywhere. Your kitchen is basically a chemistry lab in disguise. I mean, on the acid side, you've got your lemon juice, your vinegar, even tomatoes. And for bases, well, there's the soap from our mystery, of course, but also stuff like baking soda and even your toothpaste. Okay, so obviously we can't and shouldn't go around tasting and touching everything to figure out what it is. So how do we tell them apart? We need some kind of detective. And luckily for us, nature is absolutely full of them. And that's where these amazing things called indicators come in. Think of an indicator as our chemical detective. It's a special substance that changes color to give us a signal, telling us if it's found in acid or a base. This is the absolute key to solving our whole mystery. And what's so cool is that these chemical detectives are all over the place in nature. Turmeric, the star of our show, is a fantastic example. But you can also find them in things like lichens, which is where we get litmus paper from. Even stuff like red cabbage juice or hibiscus flowers can do the trick. How cool is that? Now, litmus paper is probably the most famous of these chemical detectives. It gives a super clear, no-mistake signal. It's simple. If you take blue litmus paper and dip it in an acid, it turns red. And if you take red litmus paper and dip it in a base, it turns blue. It's a really straightforward, super reliable test. But what if we want to get a little more specific? Well, for that, we use something called the pH scale. It's just a simple scale from 0 to 14. Right smack in the middle, at 7, is neutral. Think pure water. Anything below 7 is an acid, and anything above 7 is a base. So this scale just gives us a precise number to tell us exactly how acidic or how basic something is. Okay, so we've met our main characters, the acids and the bases. We know how to spot them using our chemical detectives. Now for the big reveal, the climax of the story. What happens when these two opposites finally meet? Well, what happens is a reaction called neutralization. And it's exactly what it sounds like. It's this powerful process where an acid and a base basically cancel each other out. They react and they create something totally different, something neutral. And here is the simple, kind of beautiful formula behind it all. Are you ready? Acid plus base gives you salt and water. That's it. This one simple equation is the key to unlocking so many chemical reactions happening all around us, and even inside our own bodies every single day. Let's make this real with a classic example, an ant bite. You know that awful sting? That's because the ant injects formic acid into your skin. Ouch. But what do people tell you to put on it? A little paste of baking soda, which is the base. When you apply it, the base neutralizes the acid and you get relief. See? That's neutralization in action, saving the day. And sometimes neutralization can be, well, pretty dramatic. You've probably done this one. When you mix certain acids and bases, like vinegar and baking soda, they don't just make salt and water. Nope. They also release a whole bunch of carbon dioxide gas. Enough gas, as you can see, to actually blow up a balloon. So there you have it. Once you know what to look for, you start seeing this incredible chemical balancing act happening absolutely everywhere. Think about it. You get indigestion, that's too much stomach acid. So you take an antacid, which is a base, to neutralize it. Brushing your teeth? Your toothpaste is a base that neutralizes the acids left behind by food. Even farmers get in on it, using a base like lime to fix soil that's too acidic. And big industries have to neutralize their waste to protect our rivers. It is a constant, totally vital process. And that brings us full circle, right back to where we started, with that turmeric stain. The answer was right there the whole time. Soap is a base, and our natural detective turmeric is just programmed to turn red as soon as it touches a base. So, mystery solved. So, now you know the secret. The whole world is basically your laboratory now, and you're the detective. Now that you know exactly what to look for, what kind of acid-base chemistry will you discover today?